Welcome. So in this presentation, I'll be covering a common rail injection system which is used in almost all the diesel engines. So firstly, we'll be discussing on what are the functions of fuel injection systems. One is fuel injection system should properly atomize the fuel so that it properly mixes with air. And once mixing is proper, combustion will be proper. Second thing is the spray pattern should be proper so that it covers the total cylinder and the mixture obtained is homogeneous. And the third important function is the metering of the fuel, wherein the amount of fuel which is to be injected in the engine depending on operating condition should be optimum. That means proper air fuel ratio should be maintained depending on operating conditions. And as we know, there are different operating conditions, like we have starting, idling, cruising range condition and accelerating condition. And we know that for starting and idling and accelerating condition we need rich mixture, and during cruising range we need more fuel economy, so the mixture should be lean. Now, as far as conventional fuel injection systems which were used earlier are concerned, there is a pump which is a kind of reciprocating type of pump consisting of plunger and a cylinder. So this pump is operated by means of a cam. So cam, it rotates and it reciprocates the plunger inside the cylinder of the pump, and then when the fuel is pressurized it will be supplied to the injector. Upon reaching the injector, the pressure of the fuel, it will push the needle back against the spring force in the injector, and then the nozzle opens and it injects fuel in the cylinder. Now, in case of conventional fuel injection system, the pump has to cater two functions. One is it has to pressurize the fuel, and second one is it has to meter the amount of fuel, proper metering of the fuel. And the injector will cater the other functions, like it will atomize the fuel, it will maintain proper spray pattern, it will instantaneously start and stop the injection of the fuel. So in order to meter the amount of fuel, pump has a separate mechanism wherein it consists of rack and pinion arrangement, and this rack is then connected to the governor, and governor in turn will signal rack, and in turn the metering of the fuel is done by the pump. Injection pressures which are used in conventional injection system is about 200 to 250 bar, and this gives a droplet size of around 50 microns. Now, as far as conventional fuel injection system is concerned, since the droplet size is around 50 microns, there are chances that when fuel is injected, if it doesn't mix properly with air, or if the atomization is not proper, then it may accumulate inside the cylinder. And when it accumulates inside the cylinder, then there are chances of knocking, which is undesirable as far as CI engines are concerned. So since you are using lower pressures, atomization is not very high, and this will lead to improper combustion leading to increase in emissions. Now in current engines we have a system which is called as common rail injection system, where the injection pressure which is used is around 1500 to 2000 bar, which is quite high, 10 times more than the conventional systems. Now the difference is, here again there is a pump, then there is a common rail where the fuel, high pressure fuel is supplied, and then injectors are connected to the common rail by means of a pipe. The pressure inside the common rail is maintained above 1500 bar, and along with this components there is one more important component which is called as electronic control unit, ECU unit. Now this ECU unit, it is an unit which will take feedback from various sensors. The sensors can be oxygen sensors, which are in the exhaust system, which are located in the exhaust system. It can be a speed sensor. It can be a velocity sensor, which will actually measure the air which is inducted into the cylinder. It can be connected to a accelerator pedal, which can sense the acceleration. So all this feedback is received by electronically controlled unit, and thus electronically controlled unit, ECU unit, will then decide how much amount of fuel is to be injected. So the injector of common rail system consists of a solenoid which is connected to ECU unit. Now in conventional injection system, pump has to cater two functions, that is metering and pressurizing, but in CRI system fuel pump will cater only one function, and that is to pressurize the fuel. Other all functions are catered by injector. How? In CRI injector there is a component which is called as a solenoid. The remaining components, they are same as conventional injector, which consist of a needle, a spring section, and all those things. But in addition, in CRI injector there is a solenoid which is signaled by ECU unit. Now in case of CRI system, as against conventional injection system, the metering of the fuel is also done by the injector itself. So the solenoid, when it receives signal from the ECU unit, it will open the needle and injection occurs. As soon as the current is stopped, injector will again cut off. Now when injector is to be opened, again ECU unit supplies current to the solenoid. It will attract the needle and the injection is done. Now as far as the CRI injector is concerned, here as against conventional injection system, you can also get multiple injections. Multiple injections in the sense that one injection can be divided in 3 or 4 injections. How that is done? So in conventional system, when pump is operated, it will pressurize the fuel and then it will supply it to the injector, and because of the fuel pressure, injector opens and it injects the total amount of fuel in a single injection, which is shown in the figure below here. However, in case of common rail injection system, as you can see in the figure which is in the top, there are multiple injections. The first two injections, they are called as the pre-injections. Then the third, which is the main injection where most of the fuel is injected, and then we have post-injection. Now in case of conventional injection system, when all the fuel is injected in single injection, there are chances that fuel may get accumulated inside the cylinder and it may cause knocking because of improper combustion. But in case of CRI system, the pre-injection, in which a small amount of fuel is firstly injected, temperature inside the cylinder at the end of the compression is already high, so pre-injection will initiate the combustion process and then most of the fuel is then injected. So as soon as fuel is injected, since combustion is already on, the fuel which is injected, that will immediately combust and it will burn. And when it immediately combusts, then there are very less chances of accumulation inside the cylinder. So this strategy can completely avoid uncontrolled combustion. Now there are post injections also, which you can see in the figure above, wherein the injection of this fuel during post injection will keep the temperature high, and this is useful for exhaust treatment, because when you have a particulate filter in the exhaust, the temperature for regeneration of this particulate filter should be high. So this post injection will avoid the blocking of the particulate filter, a clogging of the particulate filter, by maintaining the temperature of exhaust gases slightly higher. So this multiple injection strategy can actually reduce the pollution, can actually give us proper combustion and enhance the output without any knocking as compared to conventional injection system. So as far as advantages of common rail injection system is concerned, since we are using very high pressures, which is of the order of 1500 to 2000 bar, this high pressure will lead to better atomization, proper spray pattern, because the droplet size is directly proportional to the pressure. So if the pressure is high, the droplet size will be minimum. Then since you have a solenoid, you have a better control over the fuel injection system in CRI system. And since there is no accumulation, there is complete absence of knocking, and the noise levels in CI engines are also lower. Since we are using ECU unit which senses oxygen, air velocity, speed, accelerator movement, ECU will calculate the optimum amount of fuel which is to be injected, giving us optimum air fuel ratio based on all the operating conditions. So since we have optimum air fuel ratio, fuel economy is also better. So thank you. This is all about the common rail system.